Five basic learning rules are error correction learning. It's used for optimum filtering. Memory-based learning, used for memorizing the training data explicitly. Hebb learning, it's a neurobiological type. Same competitive learning. And final, Boltzmann learning is statistical type. So error correction learning, error signal EK equal to desired response minus the actual output signal which we have got. EK is DK minus YK of n. Cost function E of n equal to half ek square of n, instantaneous value of the error energy. Del W kj, change in weight is eta ek of n xj of n. Eta is the learning rate parameter and wkj of n plus 1, the new weight is equal to wkj of n, the previous weight, plus del w, change in weight, del wkj of n. Next, memory-based learning. All of the past experiences are explicitly stored in a large memory of correctly classified input-output. Example, xi din I equal to 1. Criteria used for defining the local neighborhood of the test vector is x test. Nearest neighbor rule is the nearest neighbor of x test. Minimum distance is the nearest neighbor. Next, Hebbian learning. If two neurons on either side of the synapse are activated simultaneously, then the strength of the synapse is selectively increased. If two neurons are activated asynchronously, then the synapse is selectively weakened or eliminated. A Hebbian synapse increases its strength with positively correlated presynaptic and postsynaptic signals and decreases its strength when the signals are either uncorrelated or negatively correlated. Competitive learning. The output neurons of a neural network compete among themselves to become active. A set of neurons that are all the same, the limit is imposed. The change in weight del wkj is eta into xj minus wkj if the neuron k wins the competition, and 0 if the neuron k loses in the competition. Boltzmann learning. The neurons constitute of a reason structure and they operate in a binary manner. And the energy function E for Boltzmann learning is minus half sigma wkj xkwj for j is not equal to k. The probability formula is this one. Boltzmann learning del wjk formula. Then mcculloch pet neuron. It's the first neural network developed in 1943. Yin equal to x1w1 plus x2w2 plus x3w3. The activation is binary. So y equal to 1 if yin is greater than or equal to theta, and 0 otherwise. And for AND function, so here we have x1, y1, x1, x2. The weight values are 1. So x1, x2 values are 0, 0, 0, 1, 1, 0 and 1, 1. Yin is x1 plus x2. So 0 plus 0. So it is 0 plus 0 is 0. So it's like an operation. 0 plus 1 is 1. 1 plus 0 is 1 AND function. And 1 plus 1 is 2. And threshold value is 2. So if the values are greater than or equal to its normal addition, then when we apply threshold value to the values less than or equal to less than 2, all these become 0 and equal to 2 becomes 1. So for 1, 1 alone we get output 1. OR function, yin equal to 2x1 plus 2x2. Since the weight is 2, same inputs. So when we add it, it becomes 0, 2, 2, 4. 2x1 plus 2x2, right? So 2 into 0 plus 2 into 1 is 2. And the threshold value is 2 here. So for wherever the output is greater than 2, y becomes equal to 1. So for all, wherever 1 is there, we get output 1. For 0, 0 alone, the output is 0. And NOT gate is 2x1 minus x2. Here weight is 2 and here minus 1. And so we have here threshold 2 value. So 2x1 minus x2. 2x1 minus x2. 2 into 1 minus 0. 2 into 1 minus 1. So we get here answer 1. So threshold value is 2. So only for this one we get output 1. Otherwise the value is 0. XOR function x1 XOR x2. So it's x1 and not x2 or x2 and not x1. So we have here x1 x2 value. Z1 in is 2x1 minus x2. It's calculated. Z1 is threshold value is 2. So only for 2 the output is 1. Z2 in is minus x1 plus 2x2. And so we find Z2 in and Z2 is the threshold value 2. Yn is 2Z1 plus 2Z2 calculated, and again threshold value is 2. So for this alone we get output 1. Thank you.